Welcome back, everyone. We're going to be solving LeetCode 102, binary tree level order traversal. So we're given the root of a binary tree. We need to return the level order traversal of all of the nodes, i.e. from left to right, level by level. So this is going to be our classic breadth first search, right? We will traverse the nodes from left to right at each level, and we will get an output. In example 1's case, we'll get an output of 3 in one level, and then 9 and 20 in the next level, 15 and 7 in the last level. So again, breadth first search uses a queue, so we're going to implement the dq from the collections library. So from collections import dq, we'll set that up. Q is going to be equal to dq, and we will put the root on initially. We're also going to have a resulting array, which is going to contain all of the levels of our tree. And we want to run our breadth first search algorithm now. So while the length of our queue is not equal to 0, what do we want to do? We want to define a level equal to an empty array, loop through all of the nodes in our queue at this point in time, and then do something. So we'll say for I in range length of our queue. We want to grab the node, which is going to be equal to queue.popleft. Right now, we have to check and make sure we are not at a null node. We can do that with if node is not none. We want to simply append the node value onto our current level. So we will say level.append node.val. Now we need to check and make sure that the node has a left and right child, and if it does, we want to append those children onto our queue. So we'll say if node dot left is not none, we want to say queue.append the node.left child. Same thing for the right. If node.right is not none, we will say queue.append node.right. Okay, now after this for loop executes, what do we need to do? We need to append our current level onto our resulting output array. So we can say if the length of our level is not equal to 0, meaning we have found nodes at this current level, we just want to append that level onto our resulting output. And then at the end, we can just return that resulting output. So we'll get rid of some spaces and we will run this. Looks like I spelled none wrong here, so let's fix that. Not valid. What did I do here? Node equals queue.popleft. Node is none. Level.append node.val is not none. Res. Aha. Res.append res. This should be res.append level. Doesn't look like I have any other mistakes, so we'll rerun. Perfect. So we do pass all 3 test cases, so we'll submit. And it does pass the submission tests. So let's see here. Time and space complexity. Time complexity is going to be O of n, right? We are traversing our tree level by level and grabbing or touching all of the nodes at least one time. Space complexity is going to be bound to the length of our queue plus the length of our resulting output array. All right, that'll do it for LeetCode 102.